This is a responsive Power App that can be viewed on a desktop, tablet, and mobile device. And in this video series, I will show you how to build yours. This video is the first in my new series on PowerApps Containers, layouts, and responsive design. In the first video, we will learn the basics of the container control. In the second video, we will then go through how to use the container control to create modern app layouts and the tips and tricks in using it to create modern UIs in Power Apps. In the third video, we will learn how to take new or existing Power App designs and make it responsive to fit whichever device is being used, be it a desktop, tablet, or mobile device. Anyway, with that being said, let's get into the video. If you've watched some of my previous videos, you will know that I sometimes use containers. Container. Okay, maybe a little more than sometimes. I'm even getting called out in the comments. But all of this is because the container control makes Power App development a whole lot easier. So before we get into how to use the container control, we first need to answer this one question. Why should I use containers? Microsoft released Power Apps sometime in 2017, and for the next 3 to 4 years, developers built what I will classify as first generation Canvas apps. These apps were generally simple apps, mostly set up with a basic gallery, form, and some unnecessarily huge icons. Yeah, I was also guilty of that. Anyway, since there were very few controls on the screen, there wasn't a practical need to group your app controls into sections. As time went on, developers not only needed a simple way to build responsive apps, but also static layout apps that contained more controls. Then Microsoft released the container control, which will then bring the second generation of Canvas apps. This second generation Canvas apps utilize the classic controls and containers to build modern looking apps with well-defined sections and content groups, whose size and position could be static, partially responsive, or fully responsive. Now, on to the next question. What is a Power Apps container? The Power Apps container control is many things and can do many things, but its basic function is to group controls. It's as simple as that. Every other trick or tip to using containers is all based on the fact that they can group controls. These child controls can be anything from a simple text label to a form to a gallery or even other containers. Since the container is also a control, we can place containers inside of a container, then place containers inside that child container, then place containers inside that child container of the child containers, then also place containers inside that child container of the child container of the...
Boy, that escalated quickly.
Anyway, you get the point. Containers can group controls, including other containers. And once they are grouped, the position and size of all child items can be controlled using the parent container. Now we know what containers are. The next step is to learn the types of containers and how to use them. If you search container in the insert panel, there are 3 types to choose from. We have container, horizontal container, and vertical container. And though there are 3 options here, containers are basically divided into 2 categories. For those who have watched some of my previous videos, you will have heard me classify the horizontal container and vertical container as responsive containers, and then classify the container as a non-responsive container. But apparently that is not the actual category name. So let's check that out. I've added one of each container type to this screen, and I've also added a black fill with 30% opacity to each of them. So using the YAML code fill, let's check the actual names of these controls. The horizontal container and the vertical container is classified as auto layout containers, and the container is classified as a manual layout container. Why am I pointing this out? This will help us understand the basic function of each container type. So let's check it out. But before that, it has come to my attention that 82% of viewers are not subscribed to the channel.
Come on now, dog. Come on, man.
If you've learned something in this video or this series, please like the video and subscribe to the channel to get notified when I release new content. So let's get back to our video. Starting with the manual layout container, I've added 3 labels as child items within the container. And as the name implies, it is a manual layout container. And this means that you have full control over the positions of all the child items. For example, you can move this label however you want, move any of them however you want, you can size them however you want. There's basically no restriction to the position of items or child items inside the container. And also you can select the container and move the container around, with the child items, and the child items, move around with the parent container. So that is the manual layout. Manual layout container, as the name implies, the layout of each of the child items can be set manually and you have full control. As for the auto layout containers, I've also added 3 child items into each of them, and the position of these child items can only be in one direction. So if it's the horizontal container, by default the direction is also horizontal, so it adds the child items from left to right. So A, B, C adds them from left to right. For the vertical container, the default direction is vertical, so it adds them from top to bottom, so A, B, and C. So the reason why I said the vertical container and the horizontal container fall under the same category is because you can always switch between directions for each of them. So it's basically just one control with the same settings. However, they have different default values for the direction. Now, since it is auto layout, you can't move the child items in the same way we are moving the manual layouts items. If you try to move it, it will always be in the same direction that has been set aside on the parent container. So you can't just move it however you want. Same thing for this one, you can't also move it however you want. It always has to be in the based on the settings you've added for the parent container. So now let's go to, let me just move this. Now let's go to the actual settings for each of the container. So dependent on whichever direction you've set, it gives a primary access and a secondary access. So if the direction is vertical, the primary access is vertical, however the secondary access is then horizontal. But for the horizontal, if you select the direction as horizontal, the primary access then becomes horizontal and secondary axis is now vertical. So for the primary axis, you can set the alignment to either make it be at the start, at the middle, at the end, or space between. So at the start is like this, at the middle it moves it to the middle, at the end takes it to the end, and space between will have space between. And it's the same thing for the vertical container, it's just in a different direction since the direction is horizontal. So I've done start, middle, end, and this is space between. And then for the horizontal for the what's it called now, for the secondary axis, in this case the secondary axis is the horizontal axis. It also has similar alignment properties. It has start, moving it to the start, it has in the middle, it has at the end, and it has stretch, which basically stretches it on the horizontal axis. On the horizontal axis, which is the secondary axis. For the horizontal container, the secondary axis is the vertical axis. So we can move it to the start, the middle, the end, or stretched on the vertical axis, which is the the secondary axis. So that is alignment. You can always play around with all of this depending on what kind of visual you're trying to achieve with the container. The next one is gap, and this one is for anything apart from space between, basically. So if you set start or middle, all items by default have no gap between each other, but then if you set a particular gap, that gives it this gap. You can always reduce it, increase it however you want. The next setting I'll talk about is the padding, and the padding is basically self-explanatory. It gives in a padding around the container. So if you set, let's say, 40 at the top, 40 at the bottom, that gives it a padding all around it. So you can also put some padding on the left also. It's basically works the same way padding works in labels, for instance. And the other one, so the size just basically determines whatever's actual size of the container. That one is straightforward. Then color, border radius, drop shadow, all those ones are, you can find them on other controls, and basically they work the same way. I will just clear the padding again, and then we can move forward. Horizontal and vertical overflow is used to determine what happens when the content of a container exceeds the size of that container. So there are two options, hide and scroll. To test this, I've added a couple more labels into the container. So when the selected option is hide, the extra controls are hidden. However, when the selected option is scroll, the container automatically adds a scroll bar so we can see the hidden items. This is very useful for cases where you need to add a higher number of controls to a screen. And I used this technique in one of my previous videos where I wanted to add more filter options to my gallery without being constrained to the size of the screen. And by adding a scroll bar, I was able to add as many filters as needed to that screen.
Not bad, not bad.
As for the wrap property, this is used to position controls on the next line when the container is smaller than the contents. This setting is mostly used when building responsive apps. And as I've said earlier, in this video, we are just treating the basics of the container control. However, in part 3 of this series, we will be covering responsive design, and then I will show you how this property works in app development. Now we understand all of this, the next part is to tackle the sizing of individual child items. So this is the part where a lot of people have issues, but I'll try to break it down as much as possible so you can understand it easily. We would use the horizontal container for this example. Starting with the secondary axis, you can set a static size to the child item when the alignment is start, center, or end. And when the alignment is stretched, what you can set is a minimum size. And in this case, that will be the minimum height. If I set the minimum height to 500 and I try to reduce the height of the container, you can see the label reducing in size to match the container. But once it gets to a height of 500, it doesn't reduce any further. This works the exact same way for the vertical container. However, the secondary axis is the horizontal axis. So what you will be setting is the width of child items. As you've probably noticed, positioning and sizing on the secondary axis doesn't have to be the same for all child items. While you can set it as a group on the parent container, you can also set it for the individual child items. So you can set it for them one by one. Lastly, as for the positioning and sizing on the primary axis, we only have two options. We either set a static size or a flexible size. In the case of the horizontal container, you can set a static width or a flexible width. Static width is pretty self-explanatory. You just need to make sure that flexible width is turned off, and then you can set whatever static width you want in the width property. As for flexible width, what this does is to take whatever space is left after the static width child items have taken their own space and then divide this remaining space among the child items that have flexible width turned on. For instance, if I set the width of label A to 100 and I set B and C to flexible width, you can see that label B and label C stretch to fill the remaining space inside of the container. If I also turn on flexible width for label A, since there are no child items with static width, the container just goes ahead to divide the available space between the three child items. By default, the container would always divide the available space equally among the child items with flexible width. But in most cases, you would want custom sizes for each of your child items. And that is where the fill portion property comes into play. What this property does is to take the total flexible space available and divide it by the total number of fill portions. Then assign it to the individual child items depending on their fill portions. For instance, the total fill portions here is 3. with label A, label B, and label C having one fill portion each. What this means is that the total available space will be divided into 3 parts, and 1 part is assigned to each child item. With this logic, you can do whatever sizing you want. For instance, if I want label A to take 50% of the width, and then label B and C should take the remaining 25% each, I will set the fill portion of label A to 2, and then leave label B and C as 1. If I wanted label B to take 60% of the width, and then label A and label C to take 20% each, I will set the fill portion of label A to 1, set the fill portion of label B to 3, and set the fill portion of label C to 1. So it's basically like a game of maths and fractions. So 50:25:25 is the same thing as 2:1:1. 20:60:20 is the same thing as 1:3:1. And if you have issues understanding fractions, a simple trick is to just apply the percentages as is. So you can add 20 for label A, 60 for label B, and 20 for label C. And you'll notice it is the same size as when we applied 1:3:1 for the fill portions. One thing to note is that for child items with flexible width, there is a property called minimum width. And as the name implies, it is basically telling the system that though this child item size should be flexible based on the fill portion ratio, its size must not be smaller than this size that I've set in the minimum width. To show how this works, I've set the container width to 1000. And I've changed the labels to show the width of each child item. So I set it to self.width. The fill portion ratio is 1:3:1. So the first and the last child item should always have the same size, regardless of the parent container size. But if I set the minimum width of the first child item to 400, let's see what happens. Item A that should have been 200 is now 400. I mean, that one was pretty obvious. We just set it to have a minimum width of 400 like 2 seconds ago. However, it gets interesting for the other 2 child items. The size of B and C is 450 and 150 respectively. And if you guess correctly, what the system is doing is to take item A a static width of 400, right? And then divide the remaining space among the child item based on their fill portion ratio. In this case, the remaining width is 600, and if we divide that based on a 3:1 ratio, right, we get a size of 450 to 150. So label B takes 450, label C takes 150. Understanding how fill portion work and minimum width and minimum heights work in PowerApps development is very, very important, especially for those building responsive apps. And as I've said, this video is just the basics. In part 3 of this series, we will be covering responsive design in detail, and I'll show you how all of this I've just explained works in app development. So make sure you're subscribed to know when that video is released. All I've just explained is the same for the vertical auto layout container. The only difference is that the layout is vertical and we deal with flexible height and minimum height instead of flexible width and minimum width. I don't want to have to explain the whole thing again. It's pretty much the same thing, to be honest.
Lazy.
And yeah, that is that as regards auto layout containers. However, some of you are most likely wondering, what about cases where we need to place items on top of each other? For example, if I want to add a background image for child item C, the label C, right? If I simply add in an image control, it will add the image control as a child item in line with other child items, which is not what we want. We want the label C to have a background image that I just added. So in cases like this, what you need to do is to utilize the manual layout container. Since the manual layout container gives you full control over size and position of its items, all you need to do is to first add in that manual layouts container as a child item, and then size it however you want. Then add in whatever items you want placed on top of each other inside that container. In our case, I will first add in that image control and make sure the image control fills the parent container by setting X and Y to 0, and then I'll set the width and the height to parent.width and parent.height respectively. Then I would add the label inside of that container also. I'll make sure to make the label fill the container also. Then I would size it as needed and style it as needed. And this way you can add items on top of each other.
Nice.
That brings us to the end of the first video in this series. And as I've said, this first video was just handling the basics of the container control. In the second video of this series, we would go through how to implement these basics we've just learned and use that to create modern UI designs in PowerApps. So make sure to subscribe and turn on post notifications to get notified when I release the next video. Anyway, if you've enjoyed this video or at least learned something, please hit the like button and follow me on LinkedIn. Thanks for watching, and I'll catch you in the next one.